We are in year 11. We are doing maths advanced. We're just attempting to do the ambiguous case of the sine rule. Very, very simple, but very complicated. So what happens is you have a triangle. You have this as 8 meters. You have this as, let's say, 6 meters. You have this as 20 degrees, and you have this as theta. So they ask you for, all right, find for me A and theta. Innocent looking question, no problems there, right? But it's actually hard because I've saved that as a worksheet and I go over here, right? So here's your triangle again. You got 8 meters, 20 degrees, 6 meters, theta. Hong Special says that you got to do the arrows, right? So you go 6 over sine of 20 equals 8 over sine of theta. Now, Vi, you and I are racing, by the way. You don't know that yet, but you can do this on your own and we can race, all right? See who gets there faster. All right, mate? So then you've got crisscross again. So you got sine theta then equals that times that, which is 8 sine 20 divided by 6. And now grab the calculator from somewhere here, and I work that out. And I'm going to go fast and find out theta as well by the sine inverse of that. And I go 8 sine 20 equals divided by 6 equals, I go the sine inverse of that equals, and I get 27 degrees to the nearest degree. All right, let me say I round that off. All right, so you found half the answer, theta. Now, how are you going to find A? Well, A was here. So that means you got to find this alpha guy. Okay, so how do you find alpha? Alpha then is 180 degrees minus 27 degrees minus 20 degrees. So if I do that right, I would get then 133 degrees. Yeah. And then you go the sine rule again, another arrow. So I go A over sine of alpha equals 6 over sine of 20 degrees. So that means that A then is 6 sine alpha over sine of 20, which is sine of alpha is 133. So I'm going to write that down. Sine 133 divided by sine 20. And what I get then is sine of answer equals times 6 equals divided by sine of 20 equals, and I get 12.8 meters. Did you beat me, Vi?
No.
No, you're still going. All right. So, by the way, you think you got the answer, you haven't. Let me demonstrate. You just found the case where I'm going to draw this. So that's somewhat to scale. So that's 8. That's going to be 20 degrees, right? So how do I make it 20 degrees? So that's got to come down here. 20 degrees means that it's got to be something like that. And that's going to be 6 somewhat, right? So that's going to be there. So that's all right. That's 8 meters. That's 6 meters. And that's 12.8 meters. And that's okay. That's 20 degrees. That's 133 degrees. And that's 27 degrees. So that's all right. That's one tick. But that's only case 1. Here's case 2, right? Well, there's a little known fact that theta that you found can also be 180 minus 27. Why? Because sine of 27 is the same as sine of 180 minus 27. Okay, so that means that it's the same as sine of 153. If you don't believe me, you go, and I'll show you on the thing, sine 27, right? Remember that number, 0.4539. And then sine of 153, it's exactly the same, right? So in other words, my angle can also be 153 degrees. That changes everything. Because from the point of where it looks like, this angle now is no longer acute anymore. It's an obtuse angle. How do you do that? Well, you just spread the 6 out, bring it closer. So the 6 now, so there's your 8. But the 6 now is like here. And that's still going to be 20. That's 8. That's 6. That's still 20. But this here now is 153 degrees. So your theta this time 3 instead of 27. And then your alpha is different. Your alpha is 180 minus 153. So then you find A by going, all right, A is equal to 6 sine alpha on sine 20. So then you put the numbers in. That's 6 sine 7 divided by sine of 20. And A now all right, so recording again. So we just lost sound, we got sound back, a vision rather, but sound back. So the answer now is 2.13. So this now is 2.14 rather 2 dp meters. So now this is shorter, right? So now you have a second set of answers, right? So that's your A. So that's A with theta. That's A with theta. 2 sets of different answers. So this is 1A, 1 theta, 1A, 1 theta, and that, ladies and gentlemen, is the ambiguous case of the sine rule. And that, when you rewind back this video, it's going to be useful. And I'll